own self-introduction. I am I was an undergraduate at Caltech, graduated in '64, graduated from Columbia Physics in 1969. I wrote my PhD thesis at a place called Goddard Institute for Space Studies, which is a major player. And across the hall from me, when I was seated there, was a man named Jim Hansen, who was Al Gore's cohort in starting all of this. So I had some little bit, introduction to a little bit of history here. Okay, my whole life I have spent as doing experimental physics. Never done any politics or anything. I talk to a higher authority, if you will. I talk to God's creation. I occasionally do theory, but only when absolutely necessary. Okay, we start out by saying, I'm talking about that there is no proof, no actual experimental proof, and I will go into great detail. I will expose some rather fraudulent facts and results from the IPCC et al. Okay, as we all know, the IPCC and their collaborators, I will refer to as the IPCC et al., forecasts an impending climate crisis with catastrophic consequences. They predict really bad stuff. Okay, this is a whistleblower talk. Okay. This, by the way, this is not easy to do. I'm accusing people of fraud. Whether it's criminal or not, I have no idea. I'm not a lawyer. Okay, basically what I have done here is a quantitative audit of their bad arithmetic, of their scientific methodology, especially on the Earth's energy imbalance, global warming, climate change, and the like. And what I found is that it all amounts to total fraudulent bad science. Expose a critical flaw in the Terra and Aqua satellites. These were the workhorses that measured. It was a total design flaw, and there were a whole series followed by a whole series of data fudges to cover up that flaw. So, okay, and I will just be showing you slides from the scientists who did the study, not adding anything. I will just be showing you exactly where to, for the fact checkers, where to find the data, just on their slides. Okay, so what the whole program of the ICCC is, they have a climate change model, which starts, is very plausible. It starts with the extraction and consumption of fossil fuels are assumed to cause increasing atmospheric CO2. Okay, the increasing atmospheric CO2 has been clearly observed by the Keeling curve. That's probably the only really good science that we have. That is assumed to create a positive energy imbalance called EEI. In turn, that is assumed to cause, that is claimed to be observed by satellite data, and I'll show you that that's false. That is assumed to create global warming, as claimed to have been observed by increasing temperature anomalies. That is clearly false. That is assumed to create climate change claimed to have been observed as an increasing frequency of extreme weather events. I will show you that that's also false. So this long chain, okay, the first part, I agree, is undoubtedly very true. The first link in that chain. But if you break any one of the other links, the whole set of claims is proven to be false. The ICCC et al. Assume that they're all true. Okay, the last of these is the easiest to break. That was all the data from NOAA. They were presented in a Physics Today article in 2012 by Gene Lubchenco and Thomas Karl. Now, Gene Lubchenco was Undersecretary of Commerce for Oceans and Atmosphere. Thomas Karl was director of NOAA's climate science program. If these two individuals couldn't get NOAA's very best data, I don't know who could. Okay, they assert that there's an increase of extreme weather event frequency, and in their title, they say it's all in the last 3 decades. And they show you 100 years worth of data, actual data of extreme weather events. They have an index of extreme weather events. Okay, here is their plot of that. And it's some mix of everything from hot spells, cold spells, landfalling hurricanes, you name it, droughts. They leave out, by the way, EF3 plus tornadoes, because as Steve Koonin points out in his book, that frequency is actually decreasing. So I was skeptical of that, and I just simply replotted their data by tracing it onto a piece of transparency, and I did that twice. And then I flipped one of them 180 degrees, and I plotted them right here, as you can see. If you look, they are mirror images of each other. I don't know which one is which, and if you can't tell which one is correctly plotted and which one is timed backwards, I assert this is a total fraud for their claims. Okay, let me go and give you a few preliminaries. Why is the Earth's energy imbalance now as the new metric rather than the old metric for global warming temperature anomaly? And break that down into 2 parts. What's wrong with using global average temperature and what's wrong with so-called use of anomalies? Okay, I think Jonathan Kohler has talked a lot about this, but we go on about global average temperature. It assumes that temperature is rising everywhere. So you need a practical definition for it, which is very hard to make. And even better, you need a definition which something can measure if you want to demonstrate it true. In order to measure it, according to the Shannon-Nyquist sampling theorems, the experimentalists in the room will know what that is, you need to measure the actual temperature roughly at a data point every kilometer, square kilometer on the Earth's surface. That's about 510 million data thermometers that you need. Those thermometers simply don't exist. Here's what does exist. I'm grateful to Willie Soon for sending me this map. This is Goddard Institute's map of where the actual thermometers are located. Most of them you'll see are in concrete jungles and suffer from the urban heat. Now, an important thing to recognize is 71% of the Earth is ocean. Okay, and when you look at the handful of spots you have measuring oceans. Okay. So you're clearly nowhere near capable of measuring. And what about in time? You need to measure this because it varies extremely rapidly, just from day to night. Nights are colder than days. You need to measure every one of these 510 million points once an hour. That's clearly impossible. Okay, next question. What's an anomaly? Why people always are talking about temperature anomalies. What's wrong with using anomalies? Okay, one excuse given is, well, this is a way of averaging. Well, if the averaging is done, there's no reason why you can't just simply present the real number, not the anomaly. Okay, how it's measured is never, on any of these graphs, nobody ever tells you. Different reporters average it in different ways. There's no standardized method for doing any of these measurements. Okay. And there's always a value 0. What is the anomaly equal to 0 mean? Okay, it is subtracted off, something that is subtracted off from their measurement, and but everybody who prints a result subtracts off a different value. So you see all of these plots from different authors. You have no idea how to link them end to end because you have no idea what the 0 reference value is. Does everybody subtract off the same reference value? Of course not. Okay. And one problem you have with this is that if you don't know what the actual value is, the number is useless to you. Like, for example, you want to use Stefan Boltzmann law, as Will Happer mentioned yesterday, to calculate the average thermal emission. You can't do it because you don't know what the actual value is. Okay, so the use of anomalies is totally useless. I call this bad science. Okay, but the IPCC loves it. For example, the Paris Climate Agreement still talking not only about limits the anomaly change, but the predicted anomaly, which tacitly assumes that the predictions are correct. Now, that was the fifth IPCC's fifth assessment report produced a graph of temperature anomalies, whereas the sixth assessment report switched over and relies more on a new metric called Earth's Energy Imbalance, EEI. Okay, now just about a couple of weeks ago, Secretary General Gutierrez declared a climate emergency now based on Earth's energy imbalance. So the things have certainly improved on that value. Okay, so everybody now agrees that the best metric is the atmospheric Earth's energy imbalance, or EEI. It was only given the initials quite recently. It's much easier and cheaper to measure, And its great value is that you can measure it using satellites. You can take enormous amount of data that you can't take on the surface. They're about the only way you could actually measure it for a full global measurement. And given what satellites measure is looking down at the Earth, the EEI is very specifically defined to be at the top of atmosphere. And so the net result, if we have no positive EEI, we have no global warming. Finally, we have something that we can tag along. Now, one little thing that tacitly mentioned, and I'll come into this is a number you kind of really need to remember, is in order to convincingly believe this, you need to measure this to a tenth of a watt per square meter. I'll get into that in a bit of detail. Now, let me get some preliminaries out of the way and give you some jargon, important. Okay, the normal scientific jargon is energy is measured in joules. Power is an energy flow rate. That's a time derivative. Is it a rate? It's also, if you have a plot versus time, it's the slope of the curve, the up divided by the over. Okay, so that's measured in watts, which are joules per second, is a rate. Okay, what power flux is a flow rate measured, and that's measured in watts per square meter. Which meters? That's the total area, surface area of the Earth, by definition. Okay, here's some IPCC confusing jargon, mostly being very pedantic, if you will. They call sunlight, we all know what that is. It's got some near UV and some near infrared and UV components. But that's called SW radiation, just to confuse you. They call far infrared the thermal heat, that's called LW radiation. There's no, spectrally, there's no overlap between the two. The top of the atmosphere energy imbalance is actually the power, it's not an energy imbalance, it's a power flux imbalance. And it's ideally measured at the top of the atmosphere. Unfortunately, it's top of atmosphere is never carefully defined. And very unfortunately, the IPCC et al. Typically ignore the top of the atmosphere requirement, and they also ignore the actually measured requirement. For example, ocean heat content is measured at the bottom of the atmosphere. And ocean heat content anomalies frequently masquerade as top of atmosphere energy imbalance. One more rather egregious cheat was from Wild et al. 2015 and 2019. They redefined the word bias as the difference between the computer simulation and the observed result. As in, don't bias my opinion by confusing me with the results. To use it in a sentence. Okay, what is Earth's energy imbalance? Consists simply of more power coming into the Earth in sunlight than there is power leaving the Earth, as in reflected sunlight and or re-radiated far infrared heat, radiant heat. We all are familiar with what that is. Okay, the difference between the two is the EEI. Okay, let me go on why we're doing all this. One of the most important laws in physics is conservation of energy, and that's expressed mathematically. Won't go into the details of how, but by the continuity equation, which is a function of Gauss's divergence theorem. And for that, all you need to imagine is, suppose you have a closed surface, like a sphere, that completely surrounds an interior volume. So the interior is distinct from the exterior. Continuity equation, conservation energy, say, so suppose you've got energy or stuff, whatever it is, everywhere and anywhere on the surface flowing in and also flowing out. Then suppose you have more and you integrate over that whole surface. If there's more power flowing in than the flowing out, Gauss's continuity says there will be a buildup of energy inside. Moreover, if you go for Boltzmann's relationship, that the energy content divided by Boltzmann's constant is a direct measure of temperature, whatever measure you want, then conservation of energy and Boltzmann's relation say that if you have more energy flowing in than is flowing out through this surface, then you will have a buildup of energy, which will be a warming. Hence, global warming is defined. Okay, so how do we do this from from a satellite in outer space? Okay, Gaussian surfaces work very nicely there because there are really only three components: sunlight flowing in, which is referred to as SWN, sunlight reflected or scattered out, and long wave heat out. You can't do a Gaussian surface for sunlight. Okay, the first drawing of this, was done by Ramanathan in 1987. Here you have his Gaussian surface. The nice thing here is that you can see here's the sunlight coming in, here's the reflected sunlight going out, and here's the radiant heat. Okay, so the total is just simply the Earth's energy imbalance is the in minus the two outs, and that ideally sums to zero if there's no EEI, which is the way Ramanathan drew it. Okay, so the calculation is very simple. There are only three lines to do the subtraction, and it's also very easy to audit, by the way. So, okay, now the sigmas here for experimental measurements, that's the standard error of the mean, typically for the, ideally for the uncertainties in the measurements, the error itself. And that's the standard formula for calculating the error of the net summation is just the root mean square error of the individual components. An immediate cross-check you get is that the final error range must be greater than any of the individual components in the sum. Okay, it's very simple. If you have more, the imbalance is times n, or the error is greater than the observed imbalances, you get no global warming, reverse, then is true. Okay, so these numbers are traditionally presented evolution of what Ramanathan started. Here is the power flow diagram from the IPCC's 6th assessment report from page 934. All of the three power flow numbers that we needed here are on the top line shown at the top of the atmosphere. The imbalance is this red arrow showing any energy going into oceans. Doesn't mean that that's true, but whatever. One thing you do need to remember from here is this very important number here, which is the total latent heat of evaporation of seawater. Okay, you are assumed that all of this is correct, and you're, let's see, did I skip a slide? Okay. Okay. First, you will notice, unfortunately, that this arithmetic is already obviously incorrect. We have these three whole numbers giving you a fractional number. How can that possibly be? Also, if you notice, you know anything about the atmosphere, the diagrams of where all these processes are occurring is totally muddled. I have an appendix to the slides if you want to know where they occur. And all of these numbers here are much greater than the so-called radiative forcing power flux due to CO2, which is only less than or about 2 watts. Okay. So very rarely, most casual readers, and I would mention that includes the National Academy's reviewers in 2025 as casual readers, assume that these numbers published are actually measured values. That's a bad assumption. If you read very carefully in all of these reports, there's a CYA, that's accountant speak for cover your ass. My wife, my deceased wife, was a CPA, so I learned this and how to do an audit, okay. That the top line numbers conflict not only with the summation, but they also conflict with numbers that they discuss in the text. And importantly, they are not measured values. There is, and if you read carefully, they say, well, these are just our best guesses. There's no scientific definition of a best guess. I'm sorry. And in fact, we will show you that those numbers have been fraudulently fudged. They have been changed, that the satellite data has been either, quote, recalibrated or adjusted to agree with the ocean heat content data. They just simply changed the numbers. And the data that went into that has been mostly fabricated. That's one of our scientific little no-nos, is fabricating data. How do you measure this? Okay, well, the best I pointed out was satellite radiometry. That was the early plan by Stevens et al. In 1981 and Ramanathan in 1987. And their very earliest data came from the Earth's Radiation Budget Experiment, ERBE, and they only looked at 4 months worth of data, even that was partially, and here's their results. Stevens et al. 1981 essentially say, well, this is what the budget imbalance that he calculated is well within the error bars. Ramanathan, as I showed you earlier, gave it as 0. Subsequent satellite data, however, are admitted to be insufficiently accurate. Remember our 0.1 watt per square meter centers. Okay, well, 16 years after Ramanathan, 22 years after Stevens et al., the earlier National Academy, 2003, says, well, the observations do not meet quality standards. 31 years later, when they finally finished 10 years of observation from the Terra and Aqua satellites, the observers, including Hansen, Loeb, Lecoyer, all say that the satellite radiometry data are incapable of determining the Earth's energy imbalance to the needed accuracy level. Here are their direct quotes and the page numbers where they actually say that. Loeb, limitation of satellite data is their inability to provide an absolute measure of the net top of atmosphere radiation imbalance to the required accuracy level. Okay, Stevens et al. Says, 2012, combined uncertainty is at plus or minus 4 watts per square meter. However, a few years later, Johnson, Lyman, and Loeb say Sarah's annual random errors are shown at 1 standard deviation, 0.1 watts per square meter. How do we get from 4 down to 1? It's a factor of 40. All right, well, okay. And Loeb et al. Go on to admit the absolute accuracy is truly daunting, and they use this fact to fudge the data. Now, one important thing to recognize here is that Johnson, Lyman, and Loeb admitted that the actual random errors are 0.1 watts per square meter. And so the 4 watts per square meter is due to a systematic error. It's a design flaw that's built into Terra and Aqua that's being covered up. Okay, this is not an easy satellite system to design. They had some very big difficulties in the design. You have to, the power in and power out are very, very big numbers. And any small fluctuations on them will kill the summation of the numbers. And if they're both varying dramatically in time and in space, again, there are huge errors. So you need extreme accuracy to make these measurements. To their credit, they got the error level down to the 0.1 watt square meter level. But that's as far as it got. There was a fatal flaw. Okay, and this was actually first noticed, or at least reported, by Hansen in 2011. These problems changing angular distribution of the scattered and emitted radiation. It isn't constant in time, over long periods of time, and maintaining the actual calibrations. Okay, so what he points out here is that when they actually added all this up, they were off by 6.5 watts per square meter. It was much bigger than any of these random errors. So that's admitting that there is a design error into the system. And then he says, because this result is implausible, instrumentation and calibration factors were introduced to reduce the imbalance suggested to that coming from the climate models, from Hansen's favorite model. Okay, and those are his words. Okay, so what is actually required to do this is a pair of very wide angle, what are called pyranometers. A pyranometer is essentially has 1 pixel of data, if you will. It gathers but a huge wide field of view. Okay, full horizon to horizon point of view. It gathers sunlight and scatters radiation through a whole variety of angles, and the variety of angles is really quite extreme because the satellites orbited 14 times a day, and the sun could be anywhere, and either in the northern hemisphere, the southern hemisphere, east or west, and you're looking down, and the angle that the light has to scatter through is highly variable. Okay? The Terra and Aqua satellites were designed using these very fancy MODIS imaging multi-wavelength spectrometers that also measure the detailed spectral properties. How much long wave, how much, okay. For image gathering, they're always looking down, and they, rather than this full panorama, they just scanned a ribbon along as they move. 2,330 kilometers wide, but it's only 10 kilometers tall in their scan. So the field of view was hardly panoramic. They missed all of this. Okay, they were in north-south orbits, and so anything scattered from the north or from the south, they could not see, totally blind to. And that was Hansen's first comment. And that was what it was the primary result. Actually, it's worse than that because the pyranometer does a marvelous job of doing the averaging if you give it a full circular field of view. But now you can't correct it because you're looking at a huge variety of source points on the surface. It's not circularly symmetric view, okay? You've got the circle that within your field of view, it's got both nighttime and daytime segments sort of randomly passing through because you're in a north-south orbit. You pass over the poles, the long day and the long night terminator, you have to cross twice a day. You have land and ocean, all with diagonal boundaries, pretty much random. You've got land, ocean, total huge amount of clouds, totally random. There's no way you can actually. So my question is, what were they thinking when they designed this? Okay, so what did they do? Well, Hansen says, well, because this result is implausible, calibration factors were used to reduce the error, the difference, okay? Suggested by Hansen's favorite model. As an alternative, okay, he says, well, what we can do is throw out all the satellite data together, and we'll just use ocean heat content. An alternative approach to measure it is via changes in ocean heat content, which he's been arguing for decades. Okay, define the word fudge. If data values don't match the preferred theory, change the data values. Okay, that's scientific misconduct number one. Okay, the execution of that plan is even worse. So what did they do? They switched to Hansen's mode. Okay, they fudged and recalibrated the data to match ocean heat content data. Now he just mentioned the Argo data. They used Lyman et al.'s data, and Loeb did the analysis of this, and the net result was no actual satellite data were included. Okay, Okay, so this is all put into a whole group report by Stevens et al. In 2012, and which effectively became the IPCC's fifth assessment report. Okay, much later, Stevens et al. Looked at this, and both Stevens and Lecuyer withdrew those results, and they actually confess to scientific misconduct. Okay, the oxygen heat content data is even worse. Okay, there's no Gaussian surface. This is to measure, okay? These are the slope of the temperature history of the water. The temperature measurements are converted to thermal energy content, and the slope of that is defined as the Earth's energy imbalance. Now, measuring slopes of curves experimentally is a real bitch. Because any high-frequency noise kills it. You can't measure what's the local slope. Worse yet, we don't have a single Gaussian surface. We got a whole bunch of oceans we got to somehow put together. Okay, so and they don't cover the whole Earth, and the Argo data are only go to plus and minus 60 degrees latitude. So all of the polar regions are totally unsampled. So much for the global energy imbalance. Okay, you cannot measure these three important numbers. Okay, and the largest influx is potentially ignored. Remember that 82 watts coming out of the ocean? That gets recycled a lot because of ocean squalls and continuous downpour in the intertropical conversion zone, but a lot of it goes onto land, and that is not accounted for. Okay, the buoy chain has 4,000 buoys. I'm just sort of running short. Where am I? Okay. Those were described yesterday by Jonathan Kohlers. The XBT, there are two groups. There's XBT data. That was preceded the Argo. That was mostly set up by the military to find the thermocline for submarine warfare effects. The XBT data, very poor data. They were basically some guy throwing a bucket over the side and sticking a thermometer in it, or going down to the engine room and looking at the engine water temperature. You have no idea where that water came from. Okay, and it ignores all of the complex ENSO current patterns we saw earlier today. Okay, and even worse, the XBT were all measured as anomalies. And well, you know how I feel about anomalies. And there were a whole bunch of teams doing it, and they all had to be patched together. So here's the data from Lyman et al. And there are two hypotheses. Okay, so, oops. Here's the early, this is the XBT data all by itself. Here is the Argo data all by itself. In between, we have a mix, a continuously varying mix of more and more Argo numbers. Now, one hypothesis that I would look at that and say, well, we have totally inhomogeneous data sets here. Okay. If you look at the data for Argo only, it's flat. No change in temperature versus time. Look at the XBT only data. It's flat. So my hypothesis would be, to do it correctly, there is no, Earth's energy imbalance is 0. That's the slope of those curves. What they did was they said, well, we'll just fit a line going through this, and this slope is 0.6 watts, 0.64 plus or minus 0.11. And that is the number that got stuck, okay? And they even recognize this, and they just simply dismiss it. Okay, Loeb et al. Tried to use some fancy analysis algorithms that they had, and Lyman et al., the best thing he could offer was, well, increase the error range. Okay, so this all gets, okay, here are his data, where he publishes in 2009, 2012, and then this gets incorporated into Stevens et al. 2012. This is a very important seminal, and they produce what I refer to as the bad penny, EEI, totally fudged. So here is the power flow diagrams from Stevens et al. Okay, and here is the bad penny. Here's the bad penny that gets stuffed in here. They use some CMIP5 computer calculations, which has a 4 watt. Which one do you want to believe? The one that they quote is the point plus or minus, because it says that we have global warming. Okay, so Trenberth and Fasulo looked at this and they said, this is totally silly. We can't really, there's something wrong with this. And they asked the question, well, where does the energy go between the two? This is from Trenberth and Fasulo. They plot a curve for time, and here's where they have a missing energy. Hansen et al. Come back and replot the Trenberth and Fasulo's calculation, and they say, no, Hansen and all say, they did it wrong. Here's what I calculate. You guys are wrong, I'm right. Okay, remember I said these got retracted? Stevens and LeCouillier just couldn't handle the fudging. So they had to fess up. Okay, LeCouillier recalculates it at all. Okay, and you get 0 plus or minus 5. Okay, here is his power flow diagram showing exactly those numbers that give you that value. Okay, then Stevens and LeCouillier together, co-authors, come in, and it's a total mea culpa confession. They say the selection was made in a totally ad hoc fashion. There is no real evidence to support one adjustment over the other. And they then give an even worse balance of 0 plus or minus 5.6. Okay, and here's their power flow diagrams. They show both the satellite and the OHC data. Okay, and here's their mea culpa summation. Okay, so, but there was a little bit of whoops. If you actually look carefully, line 5 of their abstract gives you the value 0.4 watts plus 0.6 plus or minus 0.4. How'd that get there? Who knows? Somebody apparently edited their paper and poked that number in there. That is gross misconduct number 4. Okay, if you thought that was bad, it gets much worse. Okay, between AR5 and the 6th assessment report, how are we going to proceed? Well, pretty much relies on computer simulations. Okay, the Goddard Institute for Space Studies computer simulations are using some very flawed physics. And requires, okay, so here is Hansen, who has directed the writing of this code. He says, well, discrepancies between observations and simulations are due to model efficiency, inaccurate or complete forcings, imperfect observations. But even though there are errors there, well, you should use them because they're correct. Okay, and Gavin Schmidt, who took over as director, says, we haven't the faintest idea what's going on. So the discrepancies are tabulated. Vilde et al. In 2015 was tasked with compiling all of these differences. Just how big are these errors? This is where they came up with the word bias. And they produced a bunch of bar graphs. These are the results. Each bar is some calculation by a different model or a different laboratory. The four Goddard calculations are these four in the middle. The total variation here of biases this is the downward solar radiation that was actually measured by surface stations. Was 48 watts per square meter. That's how much the lack of consensus is among the laboratories. Okay. Curiously, all these simulations end up with the bad penny. How does that get there? Apparently it's built into the CMIP5 calculation. That's what you can adjust all the input parameters, but you got to get that as the final result. Okay, they are totally incapable of describing virtually anything, if you will. Okay, this was published in the APS News. Oops. The black line is the temperature. Notice they're plotting temperature anomaly here, and they show it flattening the measured data. All these others are the model calculations. Okay, the left is historical. The colored is predictions. Which one you want to take? Okay, so these are 40 different models. So clearly we have no consensus among them. It's even worse for the albedo. Here is they're trying to calculate the Earth's albedo. That's the sunlight reflectivity. Here's the satellite data. You can convert to watts per square meter. These yellow and colored lines are all their calculations. They're off by 10 watts minimum. And they can't even get the phase right. Okay, so they proceed to compile and summarize all of these other data, and they want to add data from the surface weather, the baseline surface radiation network of measuring all of this. Okay, they have even less data available on the oceans and mostly on land. So they calculate a whole bunch of different models. Again, these are those various laboratory results. Here's a very important one, where this is the outgoing heat radiation, LW out over land. Here is their error range. Here is their fudge data value, way outside the error bars. Okay, so all these have serious disagreement between theory and experiment. You can't trust the CMIP5 worth a damn. Here is their big fudge. You'll notice if they put the land and sea on different arguments, and here they have this amazing choice that the sunlight over the ocean must be 22 watts brighter than the sunlight over land. How do the sunlight photons know to do that? to divert course. And here is that real super cheat on the long wave out. Okay, when they add them together, okay, here is their summation value. Okay, with the fudge is in, but once they add them together, you can't see it anymore. They still have results in bad arithmetic, but it's now become sort of invisible. Okay, so when 4 years later, they want to do this again in preparation for a sixth assessment report. They revert to Ramanathan's partitioning of the sky, which was clear sky and cloudy sky, except they just reused the land sea summation, saying, oh, it's got to be the same, right? And they just rewrote the name. Okay, the two diagrams from 2015 and 2019 are identical, except for the name. Okay, and here is their power imbalance, and amazo, it still has this bad penny value in it. Okay, now Stevens, Lyman, and Loeb, a priori in their paper, they assume the greenhouse gas models are causing global warming. And the best way to measure Earth's power imbalance is by using the grossly sparse, mostly fabricated ocean heat content. Okay, they reanalyze the data and they say, well, we had 0.58 earlier, but now we reanalyze it and it's now went up from 0.6 to 0.7, plus or minus 0.1. Okay, so they then, here is another totally egregious fudge. Okay. Johnson, Lyman, and Loeb use this data to recalibrate, to shift, to fudge the satellite data. And this, so that it matches the Argo results. This totally eliminates any relevance of the satellite data. And but when the national academies in their recent report read this, they didn't seem to notice this fact. And they say, wow, look how well the two agree. That means they got to be correct. And here is their fudge right here. Unadjusted, adjusted. And here's just, you couldn't read those numbers, here they are bigger. And now they say they did it one time. Nonsense, they did it twice. This is edition 2.8, this is edition 4.0. Here's unadjusted, here's adjusted. Okay. And they said, well, we use this constrainment algorithm to adjust them within their ranges to remove the inconsistency between satellites and OHC. But they adjusted this way outside their uncertainty range. So that value gets finally now taken. All of this was Wild et al. 2019, except for this number, the imbalance, which they got from that Loeb et al. Fudge. And here are their numbers. Okay, skip over these are the nickel and dime fudges they use. The big fudges are the shifting of the values done by Loeb et al. And by Wild et al. These are huge. These are the tabulation of all those for the results. Okay, this last column is the values that they all came up with. Notice it's all the same. It's that bad penny. How'd that get there? These are the actual, if you do the arithmetic of their own numbers, those are the numbers you actually get. Now, an important thing that I will get to in a moment if I have time, is that the here's the Vild et al. 2015, and here are those two fudge numbers for sunlight over land and ocean, and here is the fudge numbers for the long wave heat conduct. And here is it. They all get propagated down into 2019 and to AR's the sixth assessment report. So those are all fraudulently fudged. Suppose you undo just those three fudges. That is, you put the sunlight back to where it should be, and you put the long wave heat back to the center of their own error range. What do you get? Well, here are those lines again. Here is Vild et al. 2015 with this is the line from the previous table. Here, undoing those fudges, and the final result is you get 2 watts of cooling, not heating. Here is their bad penny fudge. Okay, so definition of the word fudge that I'm using is if the experimental data results don't match the theory, that's a scientific no-no. I'm sorry, that's serious scientific misconduct, in my opinion. They use the word constrainment. It's not even in Webster's or Oxford, to constrain, to force, or to produce unnatural strained matter. And Oxford says, force in opposition to nature. That's clearly fudging, and that's exactly what they did. Okay, and here is Loeb et al.'s direct applying an objective constrainment algorithm to adjust SW and LWT wave fluxes within their ranges to remove the inconsistency between average global toppling atmospheric flux and from the satellites and from heat storage. So, and their claim, but when you look, they're changing the measured data to match the preferred theory, but they move it way, he said, within the ranges of uncertainty. They're way outside their own ranges. They're just even lying to their own statement. Okay, so these are these various modes of scientific misconduct that I mentioned before. These are the first 3 small ones. Here is where the bad penny just getting shoved into other people's documents. I don't know who did that, but somebody did put it there so they all got exactly the same value. Here is Vild's where he has the sunlight and not knowing where to go. And here is Johnson, Lyman, and Loeb fudging their data. And the ICCC must have been complicit in this. I have no other way of understanding it. So, my conclusions. The ICCC and the contributors have fraudulently fudged their observational data and have committed fraudulent scientific misconduct on multiple occasions in order to claim falsely that there is a positive energy imbalance. I'm calling it fraud. Sorry, there's no other way to view it from my point of view. There's clearly the conclusion. The truth is there is no positive that has energy imbalance that has been proven. It could be there, but they just haven't shown it, which is their job to do. There's no proven global warming. There's no proven long-term climate change. There is no observed increased frequency of extreme weather events. That was the first one. There is clearly no climate crisis. The world is wasting trillions of dollars. It was vain attempts to limit the production of fossil fuels. If it ain't proven broken, don't fix it, especially if it costs you trillions of dollars. There is no quantitative consensus, opposite what Al Gore will tell you, about total unanimity among clan scientists. We saw that those 43 different predictions are totally all over the map by 48 watts per square meter. If they can't predict the numbers correctly, they are totally, okay. The other minor ones didn't have too much time to show, but the the effect of CO2 is totally negligible compared to, well, that's about 2 watts per square meter. Okay, the Earth's energy imbalance made by measurements made by the ICCC are both fully consistent with zero energy imbalance and zero global warming. Analysis by Lyman et al. Is clearly incorrect. A correct analysis would give you 2 watts of cooling plus or minus 4. The satellite data have clearly been fudged so that they match the ocean heat content. The best measured values for energy imbalance are probably best from Stevens and LeCoullier in their mea culpa of 0 plus or minus 5 watts. And I will note that National Academies of Science misquote LeCoullier, in this article where he is confessing, and they say, look, he proved that there is a positive. No, they misread it. He proved just the opposite. Okay, so finally, there are just serious admitted flaws in the CMIP-5 calculations, and the computer models must not be trusted at all. Okay, I think I'm only a minute over. Thank you.